Welcome to Section 34, Principal Component Analysis, or PCA. Before you get some hands-on experience coming up with PCA in the practical exercises, we're going to take a look at the intuition behind it. PCA is considered to be one of the most used unsupervised algorithms and can be seen as the most popular dimensionality reduction algorithm. PCA is used for operations such as visualization, feature extraction, noise filtering, and can be seen in algorithms used for stock market predictions and gene analysis, just to name a few. The goal of PCA is to identify and detect correlation between variables. If there's a strong correlation and it's found, then you could reduce the dimensionality, which really what PCA is intended for. You find the directions of maximum variance in high dimensional data, and then you project it into a smaller dimensional subspace while retaining most of the information. Usually, again with PCA, the goal to reduce the dimensions of a d-dimensional dataset by projecting it onto a k-dimensional subspace, where k is less than d. And for a overall breakdown and wrap up of the PCA, we can see here that the main functions of the PCA algorithm would be to standardize the data, obtain the eigenvectors and eigenvalues, to then sort the eigenvalues in descending order, construct the projection matrix W from the selected k eigenvectors, and to transform the original data set. And you can explore it further if you follow that link. But one thing I want to examine here with PCA, and I think the visualization is really helpful. If we visit the following link, it's going to take us to this page where we can actually view it in 2D and 3D examples. Now with PCA in a 2D, you can start to see the relationship and how PCA is playing out amongst the variables in the data. You can also, on this site, drag them around, drag the data points around to see the PCA, the coordinates adjust within the system. But really what I think is helpful is the 3D example. With the 3D example, you can actually see the relationship, the data within this model. Comparing it to the 2D, within the higher dimensional space, obviously it can be a much easier visualization. And I think this is helpful really to kind of grasp what PCA is doing. And if we drag the data points around again, just for a test, we can click on the Show PCA. Actually reset that and we'll show it. And we can see the PCA here. We can actually move the model around. Since it's not on that 2D plot, we can visualize it within the 3D example. All right, so to wrap PCA up short and sweet, PCA is not like linear regression, although it may look like it, because rather than attempting to predict the values, PCA is attempting to learn about the relationship between the x and y values. It's quantified by finding a list of principal axes. And I think one of the best ways is to look at the visualizations, compare it to 2D and 3D dimension, the analysis and the visualizations that we looked at before. In addition, on a side note, PCA does have a weakness. It is highly affected by outliers in the data, but PCA is considered to be one of the most used, and it's extremely popular to use. And I think once you start working through the practical, it will make more sense. If you have any questions, please let us know, and enjoy machine learning.